In example 5, we're going to be writing and graphing the reflection of an exponential function. So let's talk about reflections of the parent function f of x, which is equal to b to the x power. Reflections of the function is f of x, which is equal to negative times b to the x. So the negative sign is going to reflect the parent function. It's going to reflect the parent function about the x-axis. It's going to have a y-intercept of 0, negative 1. It has a range of negative infinity to 0. It has a horizontal asymptote at y equals 0 and a domain of negative infinity to positive infinity, which are unchanged from the parent function. And also the function f of x, which is equal to b to the negative x. So now instead of the y being multiplied by the negative sign, now the x is what's being manipulated by the negative sign. So this is going to reflect the parent function f of x equals b to the x about the y-axis. It has a y-intercept of 0, 1, a horizontal asymptote at y equals 0, and a range of 0, infinity in a domain of negative infinity to positive infinity, which are unchanged from the parent function. So in example number 5, we want to be able to find and graph the equation for a function g of x that reflects f of x, which is equal to 1/4 to the x power about the x-axis. State its domain, range, and asymptote. So if we want it to reflect about the x-axis, then that means we're going to be multiplying the entire function by a negative sign, because in this scenario here, you can see that if we're reflecting it about the y-axis, then we're multiplying the entire function by the negative sign. If we were asked about reflecting it about the y-axis, then that means that the negative sign is going to be attached to the x. So our question is asking us to reflect this function about the x-axis. And then if that's the case, that means that's why we're going to be multiplying this entire thing by negative 1. So let's go ahead and read on. Now, since we want again to reflect the parent function about the x-axis, we're going to multiply f of x by negative 1 to get g of x, which is equal to negative times 1/4 to the x power. And then we can create a table of points using all our values from negative 3 to positive 3. So what we can do is we can go ahead and open up the calculator again and go through some points. Okay, so we're going to have a negative sign, and then we have 1/4, which we're going to call that 0.25. And then we're going to raise that to negative 3. And that's going to give us a value of negative 64. Next, we're going to take it again, say negative 0.25, and raise it to the power of negative 2, and we're going to get negative 16. And if we keep continuing on, we will see that these are the numbers that we're going to get as our outputs. So we're going to plot the y-intercept, which is 0, negative 1, along with two other points. So we're choosing negative 1, negative 4, and then 1 and negative 0.25. And then also don't forget that we have that horizontal asymptote. So we have the horizontal asymptote at y equals 0. We draw our y-intercept at 0, negative 1. We plot our point at positive 1 and negative 0.25. And our other point is negative 1 and negative 4. And then here you can see that here is our smooth curve. It's increasing from left to right, but it's going towards the asymptote. So it levels off and it never touches the x-axis. Now the domain of this function is negative infinity to positive infinity. The range starts at negative infinity, goes all the way up to 0 because that's as high as it goes. And then the horizontal asymptote is y equals 0.